Hey everyone, we are on to page 11 already, so let's go ahead and start with that. For our table of contents, you need to write in storms, because we are going to be talking about storms today. So that's on page 11, so this being page 1, 3, 5, 7, 9, and then we get to 11. So down on the bottom right, we will write page 11. And then we set up our page for Cornell notes, just like usual. And you'll put your name up on the top, the date, which is 11 12/21, and then what period you have science in. All right, so at the very top, we have our topic for today, which is storms, which is always kind of interesting, I think. So our essential question for today is how do these severe weather things differ? So let's write that. How does severe weather differ? That means how are they different? So we're going to go through a bunch of different kinds of storms and talk about the differences between them. To start off with, let's talk about storms, or what a storm is. So that's a vocab word. It's just a violent disturbance in the atmosphere. So let's write that. So violent disturbance in the atmosphere. So an example of this would be like a sudden change in pressure. So let's say like a cold front hits a warm front or something like that. It's going to cause this huge change in pressure, and that's going to cause wind and precipitation. And not just like a little wind and some precipitation. Like usually it comes with very fast wind and a lot of precipitation, or different kinds of precipitation. Speaking of that, and actually maybe what's even going to happen tomorrow is a winter storm. How convenient. First one of the year. Winter storm. So obviously, since it's winter, the air temp. Oh, I spelled air wrong. Sad. Air temperature is 0 degrees Celsius or lower. And that's going to give us some snow. And some things about winter storms that cause them to be severe. The heavy snow, or even just a ton of snow. So heavy snow can, and this is like a list of things. So it can block roads. It can trap people in houses. Almost fit it all. Oh, sad. That's terrible. I'm sorry. So block roads, trap people in houses. It can actually even down power lines, and delay. How do I want to? Maybe just ambulances or something. It's emergency vehicles, but that's so long. Um, Emergency vehicles. Cool. The other thing, not just the snow, but one of the things that we have to deal with a lot is extreme cold. And that can actually cause burst pipes, and it can be possible frostbite. And you can get frostbite in about 30 minutes if it is below freezing. So that's 0 degrees Celsius is below freezing. That'd be like 32 degrees Fahrenheit. But yeah, just 30 minutes outside. Let's put that in there actually. So possible frostbite in 30 minutes or less. If it's obviously colder than freezing, like 20 or 30 below, like sometimes it gets, that time can go way down to even 5 or 6 minutes of any exposed skin, and that can get frostbite. So it's something we need to be very careful about. Okay, let's move on. Another really cool one that I personally really enjoy is thunderstorms. And that's actually one word, which I thought was interesting. So like winter storm is 2 words, but thunderstorm is 1. Just so you know. Fact. So this comes with some heavy precipitation. Precipitation, which is like rain or hail even. Some thunder. And dangerous lightning. Or I could have just put lightning. Whatever. So, typically forms from warm air. I'm just going to say warm air getting pushed up. Oh, hold on. Warm air with moisture. This W with a slash is with, just so you know. So warm air with lots of moisture getting pushed up along a cold front. So we saw in the last page that we have this warm front, or actually maybe it would be more like this, where we've got this warm stuff right here and it's getting pushed up by a cold front. So warm air with moisture getting pushed up by a cold front, that's going to cause a thunderhead is what it's called, which is kind of a cool name. And then we get these thunderstorms because it's pushing it up and cooling it down. And then the electricity or the lightning is caused by electrons. So it's an electron imbalance. That builds up and causes a discharge. So electron imbalance builds, and that equals a discharge. And discharge is just a strike of lightning. Discharge. So it's like a spark of some kind. That's a discharge. Okay, so that's thunderstorms. Super fun to watch. Very cool. The next one is a hurricane. 2 R's. case you were curious. So a hurricane is a cyclone with, there's a W with a slash again, winds over about 75 miles per hour, but it's up to 230 miles per hour, which is super fast, like ridiculous. The other thing though, because like, I mean, I can imagine a tornado getting up to that fast as well, which is what we're going to talk about in a second. But the big thing with hurricanes is that it is huge, and it can spread over or be over 400 miles across. That's massive. So it can be a huge thing that's moving, and it can last for a very long time. One thing that I thought was really interesting, that I'm going to have you put in there as well, is this wind and rain are actually spiraling inward toward the eye. And I'm sure you guys have heard of the eye of the storm. You know, like a hurricane's got that calm point in the middle. That's where it's got the lowest pressure. And so everything is starting to come in towards that, but it's spinning so fast that it's just getting sucked in that way, but it stays out because it's spinning so quickly. Anyway, super interesting. The last one is a tornado. And we are going to draw a picture for this one, because we haven't drawn a picture yet. And we'll be doing some really cool experiments with thunderstorms, because we'll talk about lightning and stuff. So, tornado, next one. Let's see. Obviously, it has a fast spinning column up there. There's supposed to be two ends here. Sigh. Spinning column of air, and it is reaching from a thunderstorm, actually, down to the ground. It is brief, usually only like around 15 minutes is the most they'll last. But I mean, they can last longer, but brief, intense, and destructive. And we can have these with thunderstorms because we have this warm air and then the cold air pushing it up. What can happen is, let's draw a picture. Oop, my ground. There we go. I'm going to put a tree. It's a very nice tree. And let's put one more. 2 trees. Okay, cool. So I have maybe this cold air that's pushing in to this warm air. And let's say this cold air ends up on top. And then we have this hot air on the bottom that is trying to go up. So remember when we had that experiment where we had the hot bottle of water on the bottom and the cold bottle of water on the top, they switched places. And the color that we added mixed throughout. So the hot wants to go up, the cold wants to go down. It's more dense, less dense. They want to switch. When that happens, it actually can cause this thing to spin. And so we got this strong wind. So this is an arrow, sorry. Strong wind. And so this is trying to go up, this is trying to go down, and that can cause some sort of spiral And if you were to see a tornado starting to form, usually it starts with a sideways spiral, like in the air, it's turning sideways, and then it'll twist to be on the ground. And so we get this, where we have this center part, just like the hurricane, we've got the eye of the storm. The tornadoes have an eye as well. And so that's a low pressure. It's trying to go down or in. And then we have this other stuff, like, so this would be the cold air. And then we have the hot air trying to go back up. And so we get this spiral. And that's how we get the tornado. So I know this is a lot of stuff, but this will be really helpful for next week when we get to do some experiments. See you later.